the grid algorithm. The proper name for it is the Jonker-Vulgenant algorithm. It is a way of solving this problem called the linear assignment problem. And what the linear assignment problem does is it takes all of our points, just looking at this right column first, it takes all of our points in a data set and tries to assign them. In our case, what we're doing here with it is it tries to assign them to a new point in another space. These are both going to be two-dimensional spaces. But because we're calling it grid, what we're trying to do is we're trying to take these data points that are sprinkled around this two-dimensional space, and we want to turn them into a grid of data points. And so that would look something like this. Starting from the big black dots as our potentially UMAP plot here, and then moving all of the points so that they form a grid on these blue dots. And you can see the linear assignment of those dots. Every black dot gets assigned to one blue dot. We can visualize it like this. Grid. There are, before I do that, we'll click it here. So here's my button for gridding the reduction data set. So FluidGrid is going to take in, it's going to do fit transform just like we had before. It's going to take in a data set that has to be 2 dimensions. And we're also going to tell it a data set that it should write the gridded points into. And that's going to be our data set here called gridded. Otherwise, everything else is just as we've done before. We normalize for plotting, we fit the KD tree, etc. But this is our the new part here that's doing the gridification, fluid.grid. And so now this is, again, a performance space that might be nice to have because we have the sounds fully spread out all over the plot. Okay. Often used for connecting a controller to this, controlling it from touch OSC or something, and then having it gridified sort of makes it more perhaps usable or having fewer dead spaces. The whole space is taken up by some sounds. A few other things with grid that are interesting is that you can do what's called oversampling. So you can create more points on your grid than there are points in your data set. And so if we do this linear assignment by oversampling, you see we still get a grid, but there are more potential grid positions than there are points in the data set. And so we'll get something that looks like this. There's also an attribute you can specify called extent, which you can specify in either the vertical or horizontal axis, a specific number of, let's call them columns or rows that you want to have. So here is specifying grid with an extent of 2 in the vertical dimension or 5 in the horizontal dimension. And so you're still going to get a grid, but you're limiting how many you can't do both, but either columns or rows there exist in your grid space that you're creating. And so this could be useful. You could now have like 5 sliders that you can move, and those sliders would be choosing different points on these, axes on this grid, and you could have 5 sounds playing at once and move those 5 sliders to choose which of the column the sound should play.